Welcome to Makino. My name is Jay Riendo, Product Line Manager here at Makino for Machining Centers. During our presentation today for the DA500, you'll notice on your screen that there's a Q&A box in the corner. If you have questions, please feel free to type those questions in that Q&A box. And either during the event or at the very end of the event, we will go through and answer those questions and have a small Q&A period at the end. So in 2018, Makino came out with the DA300. DA300 was very focused at high-speed, agile machining, high-speed production. Full 5-axis motion, small tight work zone, very efficient. We had great response with this machine. So much so that in different places we had machines being used in job shop applications, medical applications, full-on production applications, where we had great feedback that based on the performance of this machine, we want something bigger, we want something larger. We have larger parts. We want to take that production to the next level. In doing so, Makino designed the DA500. The DA500 is a larger version of the DA300. Construction-wise, somewhat the same, but now we have that ability to put larger parts in this machining center. As you can see from the diagram in the background, on the left-hand side we have the max diameter of 450 millimeters. Stepping up to the DA500, it's significantly larger, 800 millimeter workpiece diameter. That's a much larger workpiece, more capability, still full 5-axis functionality, but now we have that larger machine platform to take maybe something that was just a little too large for the DA300 and take it up to the DA500. Here's the standalone layout for the machine. Good access to the operator area, clear access for the operator to get inside the work zone. You'll notice also in this slide, we showed dimensions for a 60 tool magazine and the 118 tool magazine. On the rear side of the machine, you can see that the entire length of the machine is just over 5 meters long. That also includes the lift-up chip conveyor. Here are some basic specifications for the machine itself. Here's a small animation showing the kinematics of the machine. If you look at the structure, the vertical structure of the machine, you notice the columns on either side of that x-axis. Those are very large, heavy columns, lots of mass, as well as the lower section for our x-axis provides a very low center of gravity for that workpiece as it's moving. Along with a powerful servo system, this gives us that very tight precision movement, even when we're moving at very high speeds, moving that part around, trying to get to different features. Looking at the construction, let's take a look at the y-axis construction. You'll notice on the y-axis, we have one single ball screw, but we actually have 2 servo motors on there. Those 2 servo motors allow us to get twice as much power in that same area of the machine itself. We have 1 screw, 2 servo motors, much quicker positioning capability, much better accuracy, reduced torsional wrap-up of the y-axis ball screw. For the x-axis, we have a very large moving mass there. So in the design of the machine, we have not 1, but we have 2 ball screws for the movement of the x-axis. 2 ball screws, 2 independent servo motors for those, working in tandem together. Let's look at the column structure for this machine. In the left-hand view, you'll see a traditional design for a vertical machining center. You have the column base, then you have a saddle attached, and that saddle facilitates the installation and movement of the spindle further out front. In this arrangement, you'll notice that the spindle is a significant distance away from the column. Looking at the DA500 on the right-hand side, they've taken the saddle and installed it on top of the column, thereby reducing the amount of overhang for the spindle. This provides a much more stable structure, better performance, better cutting capability, better surface finish. Looking at the work zone also, here's full 5-axis motion. We've rotated the A-axis around, and you'll notice that as you're cutting, you have clear access between the workpiece and the lower part of the machine where the chips are evacuated in the center trough. This gives great evacuation for any material that's passing through the machine. So if you're doing large, bulky milling operations, billet, lots of chip removal, lots of material removal, we have the ability, as soon as those chips drop, we can evacuate those chips right out of the machine. Another thing to note also is, if you look at the perimeter around the sides of the machine, you'll notice that the walls are almost perfectly vertical. That way there, we have the ability to shed that coolant very quickly, get it returned back to the coolant tank, evacuate those chips outside the machining area, and continue on processing without having to go back in, periodically cleaning anything out. Let's talk about the trunnion construction. Many of the trunnions, more traditional design, those trunnions, they're looking at the motion. They're looking at taking that movement, getting that access to the workpiece itself. But they're not thinking about what it's doing as far as the center of gravity. That center of gravity is extremely important. We're trying to control that inertia at very high speeds. What Makino has done in the design of this machine is we've lowered that center of gravity. You'll notice in the machine design, that A-axis is actually set down inside the X. We've taken that center of gravity and shrunk it way, way down. That way there, we're controlling that inertia. We're controlling where that mass is moving. And by not having that mass hanging far out, we're able to provide a much better accuracy using this machine at higher speeds. Along with this, since we are moving at relatively high speeds with this machine, they've also implemented some other functionality in the machine to help control thermal stability. We're moving along pretty fast. We have 2 servos on that Y-axis. We have 2 ball screws and 2 servos on X-axis. The last thing we want to do is start to have some sort of thermal deformation for this. As part of this machine's standard, we have shaft cooling on our ball screws. That means we're taking cooling oil, which is controlled by a chiller that's being monitored throughout the rest of the machine, monitoring that machine temperature. We're passing that oil through the ball screws, we're passing that oil through the support bearings, and we're controlling that thermal stability, any of that thermal growth for any of this axis, any of that motion. This helps to increase that positioning accuracy considerably. Along with this, as you have your machine in an environment maybe where you have not such a great ambient temperature control, there's also a function called E-stabilizer. That E-stabilizer helps to suppress some of that positioning error as you see your temperatures fluctuate throughout the day. Table and pallet specifications. We can do this machine in several different configurations. If you look far to the left-hand side, this configuration here is actually a physical table with clamping cones very similar to like a traditional pallet change style machine. In this configuration here, we have a square pallet on there, and that square pallet, even though it is square, it does have turning capability. And that pallet can be taken on and off of there if you have several pallets, different work pieces, and you need to exchange those throughout the day. We have that ability to take those on and off of there. And this is a standard as it comes on the machine as we configure it here for our US market. In the center, new to this machine, we have a turning pallet. They made this pallet specific to the turning capability of this machine. 500 millimeter diameter, round pallet, perfectly balanced. One thing to note is that the cone pitch between these 2 pallets is identical, 200 millimeter cone pitch. The last option that we have is a fully integral table pallet configuration, meaning that this table is integral with the axis of the machine. This gives us the maximum height of the work pieces. You'll notice at the tops here also we have the maximum heights listed. The 400 millimeter pallet is just slightly taller, so we lose a little bit of workpiece height. Go to the 500 millimeter round pallet, we gain a little bit more, and if you need maximum workpiece height, you'd have to have some sort of an integral table configuration. Here's a little bit better view of these work pieces. One thing to notice also is that we have full 800 millimeter diameter capability all the way across the product line. A little bit of variance in the overall height as far as your maximum workpiece height. But thing to notice also is that this pallet, that square pallet that's on that machine, that pallet is fully compatible with our standard A51NX horizontal machine center pallets. So if you have work that you have turning requirements on or full 5-axis motion requirements on for machining, you can take that pallet and put it inside this machine, and it clamps up the same way it would on your horizontal machining center. Looking at the spindle tool reach capability and access to the workpiece, you can see in the views here, we show it in several different directions, including the full motion of the A-axis. Throughout this entire range of motion, you have good, clear access to the workpiece, and this also includes access to the workpiece when it's positioned in different locations, all depending on the application that you have. You'll also notice on the right, we do show maximum tool length in this view to give a better idea of what it will look like if you have an application that requires that. Here's that 500 millimeter pallet we were talking about. As compared to the 400 millimeter square pallet, this pallet is just slightly shallower, a little bit less height on it, gives you a little bit more workpiece size, and it is round to help facilitate any kind of turning or full 5-axis motion. Okay, this is where the special parts of this machine really come into play. When they designed this machine, they've designed brand new spindle options for this machine. This machine now comes standard in our market, if you were to purchase it, with a 20K spindle. And you'll also notice that power capability of this spindle is absolutely incredible. That's due to the new designs of the spindle, new arrangement, very good steady torque curve, different levels of running it at different capacities, and also very quick 0 to 20K ramp up time for that spindle shaft. Remember, when you're changing tools, when you're exchanging things back and forth, these non-cut times really come into play. This makes a very big difference in part processing. If you're doing work where you require maybe more torque, got heavier applications, other different types of material, we also do have a 14K spindle option available as well. And we have some other product families out there. These power curves are very similar on this 14K to the 14K spindlets in our DA500 IR horizontal machining center. So like I said, a little bit higher torque with the 14K versus the 20K. Just depends on the type of work that you're doing. Talk about tool magazines. Being that this machine has a really great degree of flexibility, we also wanted to provide the requirements or the necessary tools for whatever your application is. So we can show here basic standard on the machine, 60 tool capacity. We show the diameters, length, tool change time, chip to chip, relatively quick. Along with this, we have the ability to take this 60 tool ring and now expand it to 118 tools. So it means you can buy this machine as a standard with a 60 tool magazine. Later on, if you decide to put automation on the machine, add a pallet magazine, do other things with it, repurpose this machine. And as you grow, this might be something that's appealing to you. You can go from that 60 tool magazine up to 118 tools. And this magazine expansion is fully retrofittable in the field. If you want to go one step beyond, you're intending to put this machine in a large automation environment, pallet magazines, robot automation, whatever it may be, and you have a very large family of parts that you're passing through here, you're going to need a large tool capacity for this. In this case here, we have a relatively new design for this. It's a 311 tool magazine, and this is fully integrated with the machine. We also have an HMI out at the tool magazine itself. The HMI allows you to go through, select tools, read in, read out, look at the tools in a tool load station on the side that allows the operator to pull tools out very conveniently, very easily, access those tools, change them out, service them, whatever is required. Okay, we talked about the DA300 early on in this presentation. Something that's unique to the DA500, not incorporated into the design of the DA300, is turning spec capability. On this DA500, we have now incorporated the ability to do full turning operations on this machine. So not only do we have full 5-axis machining capability, now we have full turning capability as well. So up to 800 RPM as far as the workpiece rotation, 800 millimeter diameter, 435 millimeter max workpiece height with a round pallet, and also 300 kilograms of payload capacity. That's a pretty large payload that you're spinning around if you think about it at 800 RPM. Here's an excellent video of the operation cutting. So looking at this, we have full milling capability, full turning capability, and when we're going through in the turning capability portion of it, we're also locking that tool in a very rigid position. We're taking that tool, holding it in position, and you have the ability, all depending on what work pieces you're putting through there, to index that tool around to different positions, which is programmable. Along with this, you'll notice at the very bottom here, you'll see the chips, they're flying off the interior of the machine. Those chips are falling down, landing inside that center trough that we talked about a little bit earlier. Obviously in this view here, the coolant was not on, but we'd have the ability to evacuate all that material out of there. Along with this, we just showed different turning capability, both in the vertical and the horizontal attitude. Along with this, because it is more of a hybrid operation where you're going to have milling and turning, you're going to need some sort of a measuring device that's going to be able to do that for you in both fashions. We do offer options for hybrid tool measurement, laser tool measuring for typical milling operations, as well as some sort of a single point measuring devices for your single point tooling for the turning operations. Some of the other features that go along with this, for people that are more used to milling or more used to turning, since this machine does incorporate in multiple facets of that, milling and turning, they wanted to make sure that when you're in either operation, you have that ability to go through and fully understand what's going on. In this case here, if you're in milling only operation, we show a blue background or a blue banner at the top of the control panel. If you're in a turning operation, we show a green background. Very clear, very easy to understand when that's going on. We also incorporate other functionality into this, knowing that you could have potential for maybe unbalanced work pieces. You could have some changes in the mass of work pieces as you mill away and then have turning operations. We have a balance check function that's incorporated into this. And you can go through and check the balance of your workpiece. And you can also, it'll also display for you the optimum rotation speed based on the imbalance that you have that workpiece. That way there you can maintain that very good machine surface quality. And it also helps to provide a little bit better longevity to the machine itself. Here's the balance check function operation screens. Everything's listed out here. Highly intuitive, showing you how to start measuring, showing you recommended speeds. Possibility if when you go through and do this measurement, it will index around and actually get you to the point where you can add weights or subtract weights from your workpiece to get it into better balance. Gives you a good top-down view of it. Shows you the recommended rotation speed after the initial balance check. And then it shows you the balancing of the workpiece itself. Very intuitive guidance. Great, easy for operators to walk through this. Since we do have a turning functionality on this machine, there are things we have to do as far as the spindle and holding these tools in position. Traditional spindle orientation isn't rigid enough for this. So what we have done is incorporated into the design of this machine, we have a lock spline locking device built into the body of the spindle. This is incorporated into the body. Now there are other traditional designs that are out there where they take this device and just add it as a separate module, maybe just to the face of the spindle. And by doing so, it does lock the spindle, but that locking capability doesn't afford you good support for the spindle and the tool itself. You'll notice here that in this one, the locking device is forward of the bearings. In the Makino designs, we've taken that locking device and incorporated that to the rear of the front support bearings. So regardless of whether you have a spindle, which is designed for turning and milling capability, Or if you have just a traditional 5-axis DA500 with just the milling spindle, support and rigidity of that tool is always maintained the exact same way. You will not notice any difference from one machine to the next, whether it has a turning spindle or it has a traditional milling spindle. Good rigidity, good cutting performance, and remains the same for both configurations. If you do have this turning option, indexing accuracy for this tool is paramount. Traditionally, on this machine as it comes, it only comes with HSK spindles right now, 20K or 14K. But when we have this turning functionality, we have to have a different type of tool for the indexing accuracy when you're doing the turning operations. So if you have just a traditional milling machine, HSK A63 would be the standard. Turning functionality, we have now incorporated HSK T63. We've taken that distance from the tool body and out to the front edge and decreased that some, giving it more rigidity, more capability to hold on to it. Along with that T-style tooling, the tolerances between the drive keys are different. The T-style tooling is significantly tighter tolerance configuration. So when you're trying to maintain that indexing accuracy of that tool as it's contacting the part, this will provide you that better support, better accuracy, better surface finish. Along with this, we have many other functions and features that come along with the machine. Thinking about what you're going to do with the machine, maybe not now, but maybe in the future. So here's something to think about. As a standard in all configurations of machines that we bring into our market, meaning the US market for the DA500, we have incorporated as a standard on this machine a robot shutter. So when you get this machine behind these doors at the far side, you have this robot shutter that's hidden in behind there. Automation ready, very easily to retrofit magazines or robot automation. Here's an example of maybe robot automation as you were to put it on there. This view here on the left-hand side, it shows the shutter operation. And if you'll notice, this is a very large shutter, and I'll give you some perspective of what's going on here. We'll show a view right here, and this is some sort of end-of-arm tooling with a robot that's presenting the pallet inside the machine. This end-of-arm tooling is actually a very large, oversized FANUC robot. So no matter what your automation type is, even if you use a very large robot and you have this machine in other applications, or if you get the correct size robot, we have full clear access for that robot to get inside the machine and present the work to the table and clamp everything in place. Here's some examples of what you could possibly do with the machine. In this scenario here, this is a pedestal robot. And you can have single or maybe multiple machines inside of here. In this configuration right here, we have a couple of DA500s, and then we also show an expansion for another DA500 lower on at the very bottom here. And along with this, just depending on how much throughput you have on here, we can make each one of these as single or multiple height loading or stocker stations, so you can take your work pieces and store them up vertically if you have a limited amount of space inside your facility and the cell that you're going to put this in. Trying to maximize the use of that space by storing all of these work pieces up vertically. And we still have access out of the end over here where we can get to it for the loading and unloading of parts. Here's a slightly different configuration. This is a track style or a linear rail style robot. And something to think about with this, being that these machines, the pallet pitch or the cone pitch on the bottom of the table is the same as an A51NX, you can take this machine and have a mix of machines in the same cell. So you could possibly have maybe a couple of A51NXs in here. You can have multiple DA500s with an A51NX. Any combination that you want, but from a pallet handling capability standpoint, it's the same for both. Because that pallet can now go not only in A51NX, it can also go inside the DA500. Another option, new to this, DA500 pallet magazine. You can see in this view here, we have the additional pallet magazine that's been added onto the front. But you notice that from a space standpoint, it really hasn't taken up that much more space than what the original body of the machine was. It's relatively compact considering what it is. And you can see on the left-hand side, this is a view of the pallet handling arm that comes in and loads, unloads the pallet to the table inside the machine. A little bit of a better reference for you, standalone machine on the far left-hand side over here. And look at, by adding on a pallet magazine, adding on automation, we're only adding on just a little bit less than 2 additional meters to this machine. That's really not a lot of space when you think about adding automation to a machine. And the good thing about these pallet magazines is you can purchase a machine as a standalone machine and then integrate this pallet magazine later. This is something that can be done in the field, and at any time or any point in the future, if you want to change the configuration, you have that capability. Highly flexible. The other thing we had also talked about too is when you're adding that automation on, if you had purchased that machine with just the 60 tool magazine, you have that ability to expand up, get to that 118 tool capacity. That way there, when you add that automation, you'll have all the necessary tools required for that application. So pallet magazine, clean, neat, efficient handling of the pallet, compact, efficient use of floor space. You know, if you have mixed milling, mixed turning applications, you can do everything inside of there, fully integrated with machine control, and you have the choice of either a 400 millimeter or a 500 millimeter pallet. Pallet magazines. We had just talked about the ability to retrofit a pallet magazine on here. Now, all depending on what kind of work that you're doing, you may have requirements for maybe smaller parts, larger parts. You may be a full-up production shop where this machine is going to be dedicated to doing certain work pieces all the time. Maybe they're smaller work pieces. Or maybe if you're a job shop and you don't know what's going to pass through your facility, what you're bidding on, what the next job may be. We have that flexibility to configure this in different ways for you. First one on the left-hand side, if you're doing maybe smaller work pieces, we have the 8 pallet magazine. Your maximum work piece diameter will be 550 millimeters. Second selection, 600 millimeter or 680 millimeter diameter work piece now shrinks you down to a 6 pallet configuration. And then maybe you're a job shop and you have mixed work. So maybe you have some small work, some larger work. We have the ability to mix both of these in the same magazine. So in this configuration here, we have 2 pallets at 800 millimeters in diameter, and then 3 pallets at 550 millimeters diameter. Last configuration, if all you're doing is large work, 4 pallet capacity with the full maximum work zone capacity capability on the axis, 800 millimeters. One thing to note also is that we stock the 6 pallet magazine and we also stock the 4 pallet magazine as a standard. So if you decide to buy the machine, retrofit this later, we have these pallet magazines locally stocked. Always check with your local sales representative for stocking and when these will be available. Quick look at the side of the machine. Machine integrated with the pallet magazine, relatively compact. We have the operator station here, ability to load, unload parts from there, as well as the operational control display also integrated into the body of there. One thing to note also is that the control capability that you have for the pallet magazine is also available on the machine control itself. Looking at the pallet magazine, some of the features, coolant flushing. Since this is going to be continuous operation, you know for a fact, even though you've cleaned your work pieces off, tried to flush them off inside the work zone at the end of your process, chips and coolant still fall off of there. Built into the design of this machine, we have complete drip tray and splash guard design in here, where everything that falls inside the pallet magazine or off of your pallet will funnel back into the body of the machine, into the center trough, and will be evacuated by the lift-up chip conveyor. Some of the features of the pallet magazine, you notice here we have some of the operation and control on the left-hand side. You can select what work faces you have on there. You can designate 2-face, 4-face work pieces. You can go through and show what's being processed, what pallets are passing through there, what machining completion time is looking like. You can define priority for the pallet as far as its express work job may be going through, something you need to turn out very quickly in your queue of work that's passing through there. And you have that ability on the control to designate this and control this. Along with this, since we're setting up work pieces of different sizes, we want to make sure that we don't damage the machine. So incorporated into the design of the machine is a vision assist system. This vision assist system looks at the workpiece inside the pallet magazine itself, and it'll tell you whether you're within or outside the limits of what the maximum workpiece size is for that machine. A little bit better view of it over here. We display the image. Max workpiece size is way out here. Obviously, this workpiece that you see here, everything is good. We can show this image as it's looking from above and also display it on the other side of the control. Now, like I said, it's looking at that workpiece size. If after you close that work setting station door, that camera looks down at that workpiece, that software looks at it, analyzes it, looks at the diameter and yes, the height of this workpiece, and that system looks at it and understands whether or not you're going to meet the requirements. If you don't meet the requirements, if you're outside the maximum workpiece diameter size, it will warn you of that so you do not have any kind of collision inside the work zone of the machine. We had just talked about the visual pallet management, and along with that, as standard equipment on this machine, is vision broken tool sensing. This has been very popular on other platforms that we have, some of our 1 Series machines as well as the DA500. We've also added some additional features to this vision broken tool sensing system. You'll notice on the left-hand side we have the tools being compared. So tool 1235, we have several instances of where the vision broken tool sensing system took images of that tool. Now included in the capability of the software, we have the ability to detect if there is a wrong tool. And what I mean by wrong tool by the visual form or the visual representation of the tool as the image is taken for the vision broken tool sensor. So in the first photo, tool 1235 was a drill, everything appeared normal. Second photo, tool 1235 appeared as a drill once again, everything was normal. And then, assuming that something went wrong, the last image took a picture of 1235, but you'll notice that that is actually a face mill, not a drill. In this case here, the control would catch this and throw up an alarm identifying that was the incorrect tool placed in the magazine. So some of the other shared technology, we talked about vision broken tool sensing, also inertia active control, controlling the motion of the machine, all depending on how much weight it has on the axis. Advanced GI drilling, advanced GI milling, also functionality for GI breaker. Coolant system on the machine itself, it's really thinking about the production part process and about the machine running long term. Incorporated in this coolant tank, we have agitation or circulating nozzles that move coolant inside the tank. That way there, we ensure that we are not settling any of that particulate out inside the coolant tank. Along with that, it comes with a large hydrocyclone. We're keeping everything stirred up inside the tank. We're agitating everything. We have the optimum time now to take that coolant and pass it through a separator and help extract any of that contamination out that might be smaller that passed through. That's what we have to conclude our presentation today on the DA500. If you'd like to reach out and contact us if you have more questions, feel free to reach out via any method you have here on the screen. Also, we're coming today from this Experience Center. This is our portal to you. We have the ability to connect to you privately and also talk about your product, other things, other solutions you might need, as well as experience other parts of our facility here in the Makino-Mason area. Thank you. Thank you for attending today. Got a couple of questions here in the chat. First one, asking about tool sizes related to the large magazine. Yes, based upon what I had in the presentation, the tool limitations are no different for the 311 tool magazine as compared to the 60 or the 118 tool magazine. Another question, last one here. Can you use work probing in turning mode? And the answer to that is yes. Obviously, this would be beneficial in both modes. So yes, you can use work probing in turning as well as milling modes. And that's all I have for questions today. Once again, thank you very much for your time. Sorry for going a little bit long, but it's important to get all the information to you. If you need to contact, or if you need to get with us a little bit further on other topics you may have, please contact your local salesman and or the numbers that we have listed in the presentation. Thank you.